And then
No.
Yes, we can.
the
Got you.
derivative of ln x
We can see your screen.
equals 1 over x. And the derivative of a constant times a function is equal to a constant times a derivative of that function. And we did the sum and the subtraction, the difference and the summation. So a derivative of the sum of two functions is equal to the derivative of the first function plus the derivative of the second function, and then the derivative of the difference of two functions will equal to the derivative of the first function minus the derivative of the second function. This is what we did last time. We didn't do that product.
Sorry, we didn't do that last bit.
We did this one.
I think didn't we end on rule 6?
This is 1, 2, okay. 1, 2, 3, 4, 5. These two together, 6.
I remember it was done before that other example where that ended +6 and 0.
Okay. Let me see. Yes. Today we'll start from rule 7. I combined this one and this one. So we rule 6.
Yes, I remember. Actually, it was both combined. And if I'm not mistaken, you gave us some examples that we needed to try as well at home.
Yes. Okay. Today we'll start from rule 7. Says if two functions, let's say f and g, those two functions are both differentiable, then the derivative of the product of those two functions will be k. Let's say we have function f of x times g of x, right? Then the derivative of the product of this function will equal to, first, let's say you take out the first function, then you multiply with the derivative of the second function, meaning the derivative of g at x, right? Plus, you keep the second function, then you multiply that second function with the derivative of the first function. Okay, here, since we have addition, it doesn't matter which function do you start with when you differentiate. You can keep this function, you differentiate this, then plus on the second term, you keep this function, you differentiate this. Here, it doesn't matter which function you choose to differentiate first or to keep. Okay, let's do an example here on the product rule. Oh, okay, before we move to an example, do we have questions? I guess not.
Just confirm what is that in the last bracket thing?
Pardon?
Can you just confirm what is written in the last bracket over there? If What is this loss
Oh.
in the loss bracket?
Here it's f of x.
Okay, thanks a lot.
Right. New examples. Say we are given a function y equals f e to the power x, and you are asked to differentiate. You are asked to find y prime, as in the derivative of this function, right? Okay. You go back. If you are given a function, you are asked to differentiate it. You have to go back to your rules, right? Rule 1 is just the derivative of a constant, so that one is out. Rule 2 is the derivative of one function, x to the power n, a power function. That one is out because we have function times a function, right? E to the power x is out because we have x times e to the power x, not just e to the power x. Okay. We don't have lim x. Then we have c times f. C is a constant times a function, but our function is a function times a function. Okay, this one is out, this one is out. Then you move to the product rule. Product rule says it's the derivative of the product of two functions, f at x and g at x, and then you see you have two functions, the product of two functions, x and y, right? Okay, then you compare this to this, right, to our formula. If you compare these two, you can let your f at x to be x, and then you let your g at x to be e to the power x, right? Okay. The product rule says the derivative of f times g is equal to f at x times the derivative of g at x, right? Plus g at x times the derivative of f at x. But we only have f at x and g at x. But from f at x and g at x, we can solve for this. We can solve for their derivatives. And then after getting the derivative, we can just substitute them back here and then we simplify, right? So this means the next step is to find d of dx, dx of f at x, right? F at x is just x. How do you differentiate x? Again, you go back to your rules. We have x. It's like we have x to the power 1, and then we can use rule 2, right? Rule 2 says if it says the derivative of x to the power n with respect to x is equal to n x to the power n minus 1, right? Okay, this is x. We have x here. If we compare this x and this x to the power n, you can conclude from here that n is equal to 1. Then you can come back here where there is n, you substitute n with 1. Okay, so we have 1 times x to the power 1 minus 1, right? So this means you have 1 times x to the power 0. We said any number raised to the power 0 is equal to 1, right? So this means you have 1 times 1, which is 1. So we have this term, we have this term, we have this, we are left, oh, okay, we don't have this for now. So we have this, and this. Then the next step is to find this term. Okay, and we'll obtain this term from g at x, because this term is the derivative of g at x. Okay, so This is our Gx. The derivative, okay, we want to find the derivative of e to the power x, right? You go back to your rules. We want the derivative of e to the power x. Here on our rule, we have this similar function e to the power x, right? And then this rule says the derivative of e to the power x is equal to e to the power x, right? So you conclude that this derivative is equal to e to the power x. Then the next step is to substitute all these functions. It's this, and this, right? Okay, we have, okay, we want to find the derivative of x e to the power x, right? And then we said, it's f times the derivative of x, and our f is x, so it's x times the derivative of this. The derivative of this is this. Please unmute your mic. Please mute your mic. Yes. And there will be those who just log in and then be away from their laptops or phone and do something else. You forgot that you did not mute your mic. Okay, let's continue. All right, we are here. Then plus, okay, we said we keep this, we multiply that function times the derivative of this. Then the next step is to keep this and multiply with the derivative of this. The derivative of this is 1. So we have 1 times e to the power x, right? Okay, so if you simplify further, you can write this as x e to the power x plus ex. You can leave your answer here, or you can leave your answer like this, x plus 1. Since you are writing a multiple choice, if the possible solutions are they're left in this form, then you can leave it here. But if they are more simplified, then this would be your next step. All right. Do we have any more questions from this example? Yes, no.
Yes, ma'am. I have a question.
Okay. I'm listening.
I did not see where we substituted g of x, because in the beginning we did say that f of x is equal to x, and then a g of x is e exponent x. But when I am not sure where g of x, where we used it.
Okay, you know this term. This term is f at x times the derivative of g at x. Okay, so we have f at x, which is x times the derivative of g at x. The derivative of g at x is e to the power x. So do you agree that this is the first term, f at x times the derivative of g at x, right? Okay, then the next term is g at x times the derivative of f at x. The derivative of f at x is 1, and g of x is e to the power x. So this means we have to substitute 1 and e to the power x. And then, yeah, 1 times e to the power x. Okay, I see, oh, like, oh, where we are lost, where I lost you. Here, the e to the g of x is e to the power x. Then the derivative of x the derivative of f at x is 1. So we have e to the power x times 1. This is the same thing. 1 times e to the power x or e to the power x times 1. It's just that here I started with the derivative of f at x, then I said times g of x. But in the formula, I said g of x times the derivative of f at x, but it's still the same thing. Is it fine?
Okay. Yes, it is. And then can I confirm? So, okay, I see. It's fine. We used rule 7. And then, okay, can you confirm what other rules did we use?
Okay, we used rule 2, this rule,
Yes.
and rule
Okay.
7. To differentiate
okay.
x, we use the rule. To differentiate e to the power x, we use this one. But to differentiate both, we use this rule, rule 7. Okay, maybe let's do another example.
Okay.
Example 2, suppose you are given a function y equals.
Precious, mute your camera.
Y equals maybe x squared plus 3x plus 1. And this times e to the power x, right? Okay. And you are asked to find y prime, right? Okay. We said the derivative of f times g, the derivative of these two, will equal to, okay, let's say we keep the first function times the derivative of the second function, plus you keep the second function times the derivative of the first function. So it's like f times the derivative of g plus g times the derivative of f, right? Okay. We have two functions, f and g. Let's let this first function to be our f, and then we let this function to be our g, right? Okay, we'll say f of x is equal to x squared plus 3x plus 1, right?
Okay.
And then
Sorry,
you g at x. Yes.
So it means now we are using rule 4.
For
Am
now,
I right?
I'm still using it. This is rule 7, the multiplication, the derivative of two functions, f times g. This means the derivative of f times g. Here is rule 7. Rule 7 says the derivative f times g, right? And then rule 4, which one is rule 4? Rule 4 says the derivative of f plus g. Then rule 5, the derivative of f minus g. Okay, then rule 7 says the derivative of f times g. We have f times g, f plus g, f minus g. Ne? This here we have this function times this function, right? Since this function is outside this bracket, it means we have a product of two functions. It means this function is multiplied with this function, right? Meaning we have a product of two functions. There is no sign here. We don't have a positive or negative sign. Okay, if we had x squared plus 3x plus 1, maybe plus e to the power x, we would have been using rule 4. If this was a minus, okay, if this was a minus, then we would have been using rule 5. But since this is just a dot, or there's no sign, it means there's a multiplication sign here. It means it's a product of this function and this function. So we are using the product rule, which is rule 7. Is it fine?
Yes, it's fine.
Okay, ma'am, I have a question.
Thank you. Okay,
Can I ask?
we said, I'm listening.
Yes, when you're choosing which one is your f and which one is your g, can you choose any of the function to be your g or your f?
Yes, you can let any function to be f or g. Remember, this f and g are just dummy variables. It's just the way I wrote the formula. You can even have g times f here, the derivative of g times f. You see, that's why any of the variable can be f or g. Okay.
Okay, thank you.
No problem. We want to use this formula, right? And we said this is our f and this is our g. But for us to use this formula, we need the derivative of these two functions. We have this function f and g, but the formula needs the derivative of g and derivative of f. Okay, we can find these derivatives from these functions, right? Okay, let's find the derivative of f first. F prime. We'll find f prime by differentiating this. Okay. You see here we have x squared plus 3x plus 1, right? Okay. Meaning you can separate them and write them like this. The derivative with respect to x of x squared plus 3 times the derivative of x with respect to x plus the derivative of 1 with respect to x. Okay. You see here we have x squared. Go back to your rules. You compare that function with all your rules. X squared, it's like x to the power n, but in your case, your n is equal to 2, right? So it means on that term, we can use this rule, right? And we have, okay, this is still the same. And then we have the derivative of 1. 1 is a constant, and we said the derivative of a constant is equal to 0, right? Okay, so we will use those rules, okay? The derivative of x squared is, you take n down, which is 2, then you subtract 1 from n. So you'll have 2 minus 1 plus 3. Okay, here in this case, your n is equal to 1. So this means you'll have 1 times x to the power n, your n is 1. Then you subtract 1 from your n, right? Plus the derivative of 1. 1 is a constant, and we said the derivative of a constant is 0. So it means we have plus 0. There's no need to write plus 0, but then it's fine. It's okay. Then you simplify further. Okay, you have 2x to the power 2 minus 2 minus 1 is 1. So there's no need for us to write 1 there. Then plus 3 times 1 times 1 minus 1 is x to the power 0. And we said this is equal to 1. So this means we have something like this: 2x plus 3 times 1 times 1. 1 times 1 is 1. So this means we have 2x plus 3 times 1 and 2x plus, okay, 3 times 1 is 3. So this means we have 2x plus 3. And we cannot simplify further from here. So we can say your f prime is equal to 2x plus 3, right? Okay, now we have f prime, we have g, we have f. The next step is to solve for g prime. Okay, we can solve g for g prime from g by differentiating g. Okay, so you say g prime is equal to the derivative of e to the power x. Yes.
Before we continue, can I ask where did we get the 2 here? Because I can get the other ones. The after f is equals to d times dx, that formula. Where did
we are using this rule. Says if you have if you are differentiating x to the power n, you take n, you multiply with it times x to the power n minus 1. So that's why we took 2, we multiply 2 with everything. So we have 2 times x to the power 2 minus 1. You just come here where there is n, you substitute n with 2. But if you have but says the derivative of x to the power n is equal to n times x to the power n minus 1, then come here and substitute n with 2. So you put 2 here. If you put 2 here, that means you'll have 2 times x to the power 2 minus 1. That's why we have 2 times x to the power 2 minus 1. Is it fine?
Sorry, ma'am, can I ask a question?
Yes, I'm listening.
In the exam, will it be necessary to write all the steps, or you can just skip some other step and then write the final answer?
You can just write the final answer. We are writing multiple choice, so you'll have to like exactly the right answer, choose the right answer. I don't need these steps. I'm just showing you how you get to the right answer.
Okay, thank you, ma'am. And the other thing that I wanted to ask is that on the assessment, the second assessment, there are some questions that don't have equations. So what do we do about that?
Question assignment 2.
Yeah, assessment 2. There are some questions that don't have equations. So we don't have anything to work with. They're just answers to choose, but then no equations. So basically, they don't have questions.
Are you given a statement there?
Yeah, you just given a statement, evaluate, and then there's no equation, and then there are answers to choose from.
Just evaluate, or like we are given a scenario, then you have to come up with equations from there.
No, it's just written evaluate, and then there is no equation to evaluate, and then you are given answers to choose from.
I didn't do the assignments, but I did check all the assignments today. In fact, yesterday. Maybe you had a problem with the network. That's why the equations were not loading, but all the equations are there.
Okay, sorry, ma'am. I'll check again.
Okay. If still you don't get the equations, just take a screenshot and send that screenshot to the modules email.
Thank you, ma'am. I'll do so.
But I do believe you had a network issue because I did check all the assignments yesterday.
Okay, ma'am. I'll do so. Sorry.
Ma'am, if I may.
Yes.
Yes. Do we need to worry about trigonometry? Because as when I was doing some examples, especially the G function, it was combined with it was something like e to the times sine x. Then you're asked to
There was what? That example was
E to the
okay.
power, yeah, it was e to the power times sine x. The sign for
As in e to the power x times sine x. This.
Yes. We need to worry about those type of.
Nah, don't worry about trig. It's not covered in this module. Okay, any more questions or can we move on?
Hi, ma'am. Sorry.
Hello, ma'am. I have a question.
I'm listening.
Okay, you can go. You can continue. I'll do after you.
Oh, okay, ma'am. Can I ask?
Mm-hmm.
Okay, we had 2x exponent 2 minus 1. Can you please show the screen, ma'am?
We had 2x. Yeah.
Yes, there. Yeah, I think 1, 2. It's the second or the third. We had on your answer. Yes, we have 2x exponent 2 minus 1. So the next step, what we're supposed to do, that exponent 2 minus 1, it's supposed to be 1, right?
Yes.
But on the next, you lost the 1 there.
There's no
before
need to
you
write
go to your final
1. There's no need to write 1. You see here, even here we had x. Then there was no 1 on top, but I said since it's just x, assume that your n is 1. There's no need to write to the power 1. We don't write to the power 1. It's like something like this. 1 times x. We don't write something like, we don't write 1 here. We write x. We assume there's 1 here. Same thing as x to the power 1. We don't write 1. You just assume there's 1.
So it means that
if we are given 3, just 3. Like from here, you can assume that this 3 is to the power 1, because 3 to the power 1 is the same thing as 3. And again, 3, you can put 1 here. 1 times 3 is 3. So there is no need to write this or this. If it's like this, you assume that there is 1 here on top or there is 1 here in front. That's why here I said, okay, in this case, your n is 1, because I assumed that there is 1 here.
So if I had using that rule whereby x to exponent 1 equals to 0, then I would have been wrong.
Which rule? X to the power?
Okay, no, it's not really a rule, but x to the power 1, it equals to 0.
X to the power 1 is equal to 0.
Yeah.
How so? X to the power 1. X to the power 1 is equal to 0.
And then
where did you take this? Or you meant x to the power 0 is equal to 1?
X to the power 0 is equals to 1.
That's what I use here.
And then
that's why I have 1 times 1. Remember, I had 1 times x to the power 0. Then I said, okay, this is equal to 1. That's why I have 1 times 1.
So so it's also, even if the final answer it was 2x to exponent 1 plus 3, are you saying that it will be the same as that answer you've written, even if I don't have exponent 1 next to x?
You will never find an answer like this. You never okay, you can't leave an answer in that form. Okay, imagine I tell you that you leave 1 here, and then I give you the same question on the exam. You see there is no power 1. You'll say the question is incorrect because there are no true options. One of the options that you worked out to. It's the same thing.
So the
It's
exponent 1
the same
automatically, I
thing.
can just remove it.
Yes. You don't have to write it. It doesn't make sense if it's written there. It's like this. It's like something like this: 1 times x to the power. Okay, like here, 1 times x, right? 1 times x to the power 0. There is no need to write this 1. I'm just writing 1 because I'm trying to show you all the steps, but there is no need for us to have this 1. Yes.
Can I ask that people go and do their simple mathematics things, because now we're gonna waste our time explaining simple things.
No, just hold on there. Just hold it there.
No, I don't think that's correct to say.
Like, for me, I don't care if there is 1 student who get 100.
Yes.
I have to help all of you. I have to make sure that you guys understand.
Thank
At
you.
the end of the day, even if I take the whole period doing 1 example, it's fine as long as everyone gets to understand. That's the reason why I'm here, to help all of you understand.
Thank you, Ms.
I don't want to
Thank you so
get
much.
50% pass rates. I want 100% pass rates here.
Yes, thank you so much.
Just to
Most
chip
of
in,
us
Mrs.
don't have
Ngomo.
that background as well. So guys, you need to be respectful as well, because some of us don't really have that maths background as well. And we're doing it after a while. So it's taking us some time to understand it also.
Mr. Ngoma, just to chip in. I'm Mr. Ngoma?
Yes.
Just to quickly help Tabi saying, I think Tabi saying the way to grasp this is that any value to the power 1 equals to that value. So any value or any variable that has power 1, you don't have to write power 1. It equals to that same value. I think that's what Ms. Ngoma was trying to reiterate. I'm not sure if you understand.
Okay. Thank you very much. I think I understand. Maybe my problem was that I thought any number to exponent 1 is 0, which was totally wrong. Okay.
The wrong way.
Yes.
Okay.
Thank you very much.
Okay, then the next step was to find the derivative of g. Okay, g is e to the power x, and we want to find the derivative of e to the power x. We go back to our rules, right? Yeah, we have this rule. This rule says the derivative of e to the power x is e to the power x. So we come here, we substitute that derivative with e to the power x. We have g, the derivative of g, and g, the derivative of f and f. Then you substitute them back here, right? Okay, f times the derivative of g. The derivative of g is e to the power x. E to the power x times f. Our f is x squared plus 3x. Is it minus 1 or plus 1? Okay, then let's just say plus. Then
plus 1.
All right. Then plus g times the derivative of f. Okay, g is e to the power x. The derivative of f is 2x plus 3. Okay, this is our answer. If you're given something like this and you're asked to differentiate it. Is it fine? Okay, we do one more example, then we move on, or it's fine. I give you the questions to do in your own time.
One more example.
Sorry, ma'am. Can I ask? Can you go to
Yes,
to the last day, please?
Yeah.
Ma'am, can we please do one more example?
So when we get here, ma'am. Sorry, ma'am. Can I just quickly ask before you move on? So when we get here, there's no need for us to simplify this further. We can stop right
You
there.
can simplify further, but then at the same, okay, if you see in your multiple choice, one of the options is this one, then you can leave it here. If the options are more simplified, then you can simplify. You know that it's either you take out e to the power x as a common factor, and then you add everything, this and this together, or you take this and multiply, you do the long way. This multiply this, multiply this, multiply this, plus this multiply by this, by this. It's up to you. It depends on the solutions there. If this is one of the possible solutions, then you leave it here. If they are more simplified, then you simplify ones.
Okay. Thank you, ma'am.
Something.
Let's do this.
Sorry, ma'am. So
yes,
on making an example on the maybe assignment or what or exam, will they ask simplify further, making maybe how can I put it? Maybe if they say they give us a statement or they ask a question, say it simplify further, are they indicating that this must be simplified further, or they just going to ask for an answer? Because it's going to be confusing. Sometimes we can just waste time on simplifying. All along, they just needed that.
And in the exam, like in the assignment, you are given answers. You just have to choose the correct answer. If you leave your answer here and you see that there is no, okay, from the possible solutions, they don't have this as an option, right?
Okay.
You see that the answers are more simplified, then you are forced to simplify it. But if they are not simplified, then you can just leave it here. The thing is, I can't tell, I'm not the one who said the assignment, but I'm typing it and I'm still in question 15. So yeah, I can't really tell if all the answers are more simplified. You have 25 questions. I still have 10 more questions to type.
Okay, ma'am.
And this is here right now.
Hello, ma'am. Can I chip in maybe?
Yes.
Oh, I just wanted to maybe explain a little bit. I don't know if maybe I could be wrong. You'll rectify me.
Yes,
I think in the exam there is only multiple choice.
Yes.
So we are not going to submit the scripts that we are writing the expressions on it. So my understanding is that you are going to do your own notes as you are writing, and then once you arrive to the answer and it's on one of the options, you just select that. You don't need to simplify further because you have reached the answer. Unless if you have not reached the answer, you can simplify further until you get the answer. If you don't get the answer, that means you are possibly wrong or whatever the case that may be. I don't know.
Okay, now I'm being answered. Thank you. Because I was just thinking, if could they say maybe simplify it further, or how will they put it? So now that you're saying if you work your answers out and you haven't reached that answer, that means you haven't gotten to what they wanted. So now it's clear now. Thank you.
Sorry, can I ask? When I'm doing my calculations here, I'm always putting vice versa to yours, but I'm getting exactly what. Is there anything that I'm doing that is wrong, or it doesn't matter? Like, The last one, my
Remember,
answer goes. Okay.
I said for the product rule, doesn't matter which function do you decide to keep first and differentiate. Because
Okay.
here we are keeping first, I said we keep first this, we differentiate this. Okay, so we have f times f prime. Plus we keep this, we differentiate this, right?
Okay.
Since here we have plus, we have positive, right? It doesn't
Yes.
matter which one you keep first, which one you differentiate first.
Okay.
But if this sign, maybe it was negative, okay, you'll see from this, the other row. That's why I keep on emphasizing that here, it doesn't matter which parts do you start with.
Okay.
Oh, I think it's, did we do this row? Did we do this rule last time? Because here it does matter which function do you start
Oh
with.
no.
The
No, I
chain rule.
didn't attend the previous class, so I just typed.
Please go back to the last video.
Okay.
But did we do a chain rule?
A chain rule, no.
We
We didn't do a chain rule. No,
I
we
don't
didn't.
remember us doing it now.
No, this is not a chain rule. This is a quotient rule. We didn't do a chain rule too. But we'll do it today. It's fine.
Ma'am, I had network problems. Can you please just maybe go over the example you're going over now so that I can get a better understanding of what's going on?
I'm about to do another example.
Okay, thanks.
It's the similar thing that we are still using product rule. Okay. Here we are given f of t is equal to square root of t times everything that is inside the bracket. Okay. If we compare this function with other function like derived, differentiated in all the rules, you'll notice that you can, okay, you're supposed to use a product rule here since you have a product of two functions, right? Okay, first I let this to be my f, then this to my g. Okay, so it means we want to find f times g prime. Okay, if I write f times g prime like this, it's like, okay, this means I want the derivative of f times g. It's just the notation that I'm using. Okay, we said the product rule says, now let's keep this function and differentiate this so that you'll see that we'll get this similar things, doesn't matter. Okay, let's say we keep g, we differentiate f, plus we keep f, we differentiate g. Okay, we have g and f. We want f prime and g prime for us to use this formula. Okay, we can find those here from this function. Okay, f prime, we'll find f prime by differentiating square root of t, by differentiating this. Okay, let me just put this b of d dt. Okay, the reason we don't have x here, we have t, is because this is a function of t. This function, it's in terms of t. If here we had x, then we would have differentiated with respect to x. But it's in terms of t, meaning we have to differentiate with respect to t. Okay. Okay, if this function is like this, you take it and go to all the rules. You'll see that there is no function that matches with that function, square root of t, right? But we did grade 8, right? I know the math is not the requirement for this module. That's why I keep on going to grade 8, because I know you all did math there. No one will say they didn't do math at grade 8. Okay, so you know that square root of 2 is the same thing as square root of t is the same thing as t to the power a half. Okay, so this means we'll write this like this: dt times t to the power a half. Okay, and like if you have t to the power n, maybe root m of t to the power n, this is the same thing as t to the power n over m, right? If you have root t, you just assumed that here you have 1 and here you have 2, because square root equals, yeah. So you'll say 1 over 2. If you had something like this, maybe m root t. Remember I said you assume here there is 1. So it's like you have t, this is the same thing as t to the power 1 over m. If, okay, you have cube root of t, this is the same thing as t to the power 1 over 3. If you have 3 root of t squared, this is the same thing as t to the power 2 over 3. Okay, let's move on. We are here. Okay, then now you have, if you simplify this, you have t to the power a half. Remember, we are trying to differentiate this function, meaning we are trying to find the derivative of this function. Then we haven't differentiated it. Since we have simplified it, we can go back to our rules to check if we have any rule then that can help us differentiate this function. Okay. Let's go back to our rules. We have t to the power a half, right? Go back to rule 2. Someone please mute your mic. See, if we check rule 2, the derivative of x to the power n, it's like in our case that n is equal to a half. So this means we can use this rule. We can just come back here where there is n, we substitute n with half. So this means we'll have half times t to the power half minus 1. Okay, let's go there. Half times t to the power half minus 1. And this is the same thing as 1 over 2 t to the power minus a half. Okay, we can leave it like this. Okay, there's one more thing I want to show you. 1 over n is the same thing as n to the power minus 1, right? And 1 over maybe n squared is the same thing as n to the power minus 2. Okay, 1 over n to the power maybe 3. It's the same thing as n to the power minus 3. This is where I'm going. You can leave your answer here, but if it's more simplified, you see, if we have minus 3, is it n to the power minus 3, that is the same thing as 1 over minus 3. Okay, this is where I'm going. If this was more simplified, then we are supposed to write this as 1 over t to the power half, this part. We have t to the power minus half, and then if the power is to the power minus half, you take everything, you divide, like you say 1 divided by that function, but you make it positive when you put it as the denominator. Yes, so that's why we have something like this, right? But we said this. We said root t is equal to t to the power half. So you can leave your answer here. 1 over 2 times 1 over root t. You can leave it here if it was more, if your answer is more simplified. But for me, let's just leave it here for now. Okay, now we have f prime, we have g, we have f. The next step is to find g prime, right? Our g is 4 plus 5 ln t. Okay, we want to find the derivative of 4 plus ln t. We want the derivative. Okay, we can separate this and write this as d over dt of 4 plus d over dt of ln t. Okay, 4 is a constant. We said rule 1, the derivative of a constant is 0, right? So we have 0 plus.
Ma'am?
Yes.
Sorry, ma'am. Did you not have 5 ln t in the original equation?
I had
For
5
g
ln
of
t.
x. Yes, can you
Okay,
go
we
back a bit?
can write 5 here. I write 5 here, it's fine. We're still going to get 0, but thank you. Then the derivative of 5 is 0. Then we want the derivative
ma'am.
of ln t.
You had 1
No,
plus
it was
5
4
ln
plus
t.
5 ln t. 5 ln t. 4 plus 5 ln t.
5 ln t.
4 plus 5 ln t. You want the derivative of this. Okay.
4
You'll
plus
say
5.
the derivative of 4 plus 5 times the derivative of ln t. We said the derivative of 4 is 0 plus 5 times the derivative of this. Then we go back to our rules and see which rule can we apply here, right? Okay, here is our rules. We said we have this rule says the derivative of ln x is 1 over x. Okay, we have ln t. So this means the derivative of ln t is 1 over t. 1 over t. So this means we have 5 over t. You can write 5 over t, or you can write this as 5 times 1 over t. It doesn't matter. It's the same thing. Okay, now we have, how did we put our fg prime? Okay, we wrote it like this. fg prime plus g f prime. Okay, start with f. What is our f? Our f is root t. So we have root t times the derivative of g. The derivative of g, we said it's 5 over t plus g. G is 4 plus 5 ln 5 ln, okay, 5 ln t, then times the derivative of f. F is root t, so okay, let me just write it like this.
Sorry, ma'am,
Times,
is that not prime at the end, f prime?
yes,
Sorry, ma'am, is that not g times f prime?
g times f prime. This, it is g times f prime.
What is f prime? Is it equal to root t?
We said f prime is, yeah, is f prime. We said we can leave it, oh, we said we can leave it here as half times t to the power minus half. Okay, so 1 over t, t times minus a half. Or we can leave our answer like this: 5 over t times root t plus 1 over 2 times 4 plus 5 ln t. Okay, times 1 over root t. You can leave your answer like this. You were asking for this one, right? F prime.
Yes,
For
no,
f prime,
yes, you answered
this
me, ma'am.
is our f prime, and this is our f.
Yes, I did not see f prime earlier, so I must have PC. Sorry.
Ma'am,
No problem. Yes.
Can you please explain the simplification?
Which one? This.
For the last example we're doing, the line
The last line.
The last line.
This part or this part?
The very
The last
last
line.
one.
Next to equal, the last line.
The last line.
I'm asking here, this is a simplification of this. This is the simplification of this. That's why I'm asking if this simplification or this one.
Both of them.
Okay, this one, it's the one that I was explaining here. I was doing examples of here and here.
Okay, ma'am.
Okay, I said square root of t is equal to t to the power a half, right?
Yes.
Okay, cube root of t to the power n is the same thing as t to the power n over m, right? If there is no number here and here, you assumed here you have 1 and here you have 2, right? That's why we have t to the power 1 over 2. Okay, if you have something like this, cube root of t, you assumed here you have 1. So this is the same thing as t to the power 1 over 3, right? Okay. This is the part where, okay. And here, all right, I'll come back here. So if you have t to the power a half, you can write that as square root of t. If you have t to the power 1 over 3, you can substitute that with cube root of t, right? So, and then again, if you have 1 over n, let me say 1 over n squared. This is the same thing as n to the power minus 2, right? If you have 1 over maybe 3 to the power 4, this is the same thing as 3 to the power minus 4. If you have 3 to the power minus 2 minus half, this is the same thing as 1 over 3 to the power a half, right? If we have 3 to the power minus 4, this is the same thing as 1 over 3 to the power 4. If you have n to the power minus half, it's the same thing as 1 over n squared, right? There we had t to the power minus half, right? And I wrote that as 1 over square root of t, right? It's because we said t to the power minus half is the same thing as 1 over t to the power a half. But t to the power a half is the same thing as square root of t. So that's why we have 1 over square root of t. Yeah.
Okay, I see.
Okay.
Sorry, ma'am. Sorry.
Yes.
Isn't it supposed to be 1 over 2t to the power of negative 1 over 2? Didn't we derive?
Yeah.
Oh, what's that?
1 over
1 over 2 t into the power negative 1 over 2.
Multiplied by that, yeah.
Oh, you want to know where this is, where did this half went to go to? Where did I put it? It's this half.
Or why did you separate it?
Because it's in maths, we always start, okay, if we are writing a function, we always start with the constant first, then you write the function. It's like, okay, it's like you guys, you want me to write x5. Remember, if you to pronounce this, you have to say 5x. You can't say x5. It doesn't really rhyme, right? I don't know. So that's why I took half to this side, because we have to always start. My son is calling late. You always have to start with the constant, then times a function. That's why I took this half here, and then I started with it first. That's why here, like, look at this function. We don't have lim t5. We have 5 lim t, because this is how we write our function. Is it fine?
Makes sense, yes.
It's clear, ma'am. I understand. Thank you.
Yes, yes.
Okay. Is it fine now? Let's move
Yes.
on. Please try this one at a time.
Sorry, ma'am, I have a question.
Yes.
Sorry, I have a question.
Yes.
Okay, can we go back a little bit on example number 2? I think I lost something there. Hello?
Still here. Where did you lose your thing? Is it here?
Okay, on example number 2. Our second example.
Example number 2. Yes, I'm on the second example. I should go to which part on the second example because I'm on the second example right now. Can you guys see my screen?
Yes, we can.
Okay, this is not one
Yes, we
I'm
can.
referring to.
Oh, okay, thank you.
Can you go to?
This is the second example, the third one. I think it's the third one.
This is the third one, the last one.
This is the third example.
The same.
Okay, I think this is the second example.
Okay, I can't see it on my. Okay, yeah, this one. Can you go to the answer? There's something. There's where I got lost on the answer.
Where did I lose you? I think this is the answer.
Okay, it says e to the power x. Okay, and then it's x squared plus 3x plus 1. And then it also said plus e to the power x again, of which the equation. So it is supposed to be like this.
This one.
E to the power x.
This e to the power x is for a derivative. Then this e to the power x is for a function. Remember, if you differentiate e to the power x, you get e to the power x. And this is the derivative. Remember, we said a derivative times we keep this function. Plus, we keep this function times a derivative. So this one we kept. This one was a derivative. Okay, that's like I have to. Yeah, which one was?
Oh,
you sure now? Okay, your G at X was
I do
e to the power X, and your G prime at X is also e to the power X, right? And then we said our thing it's G prime times F plus G times F prime. So it's G prime and G. Okay, this is F. This is our F. This is our F prime. This is our G prime. This is our G. Remember, G and G prime are the same because if you differentiate this function, you get that same function again. You just have to familiarize yourself with the rules.
All right, thanks.
You sure?
Yes.
You know what? I'll go through the recording again. I'm sure I'll get a full understanding there.
All right, thank you.
Sorry, ma'am.
Thanks.
Yes.
So, can we simply say maybe any exponent on E when it's and when we do the derivative of it, it becomes the same. It doesn't change.
No. No, because remember when I was doing those rules at the end, I said I'm still going to show you how to differentiate maybe something like this. Because something like this, you'll get 2x, about 2e to the power 2x. And something like this, e to the power, maybe, let's say, x squared. Here, you will get 2x e to the power x squared. So you can't assume that all the exponents of e, like if we differentiate something with the exponent of e, we'll get that function as it is. Okay, if we are differentiating e to the power t, you'll get e to the power t. But if here it's now like maybe a constant times t, then it's something else, another rule. We're still going to do that rule.
Okay, all right.
Okay,
No,
if it's this, then you get this. If it's e to the power, if it's e to the power just one variable, then you will get that function as it is. But if it's e to the
Okay.
power a variable times something, or a variable squared, or maybe e to the power maybe root x, here you'll have 1/2 times x to the power minus half e to the power root x. You'll have something like this. So we cannot always assume that you'll always get this function. If this function is just e to the power one variable, just a variable as it is, then you can conclude that that function will give you the same thing.
All right. Okay. No,
As well as ln x. If you differentiate ln x, you get 1/x. But if you differentiate 2x, it's something else. You'll get 2/x. And if you differentiate ln x squared, you'll get 2x over x squared, and this will give you 2/x. Okay, like if you're differentiating ln x cubed, then you'll say 1/x cubed times the derivative of this. The derivative of this is 3x squared. Then you simplify. If you simplify, you'll have 3/x. So you see, these two functions are different. That's why I said I will give you the simple one, but we continue. Okay, it ends there. Once it's have a constant or it's a function, then it's something else.
Oh, okay. No, I understand, ma'am.
Okay. Can we move on to another rule?
Yes, please.
Eight. Okay, this rule 8 is called the quotient rule. Okay, here, if you have a function, if this works, if you want to find the derivative of the function over a function, like let's say if we are told that f and g are differentiable, then you want to find the derivative of f over g. Okay, the derivative of f at x over g at x. Okay, you want to find the derivative of this f over g. Here, it doesn't matter which function you start with. Here, you'll always start by differentiating the first, the upper function, and then you keep the lower function. Okay, so here we keep the lower function, we'll have g at x times the derivative of the upper function, which is f at x. Then minus, now you keep the upper function. So we have f of x times d over dx times the derivative of the lower function. Then everything over the lower function squared. You see why here it does matter whether, okay, like it doesn't matter which function you start with. It's because of this negative, because we subtract the derivative of this times this. But if we had a positive here, it wouldn't matter, because since here there is no sign, we know there is positive, right? But now there is negative. If you start, if you keep this, you differentiate this, then you subtract, you keep this, you differentiate this, your answer will be wrong. And be careful, the answer is part of the solutions in the exam. So if you do it like that, you will find the solution as part of the options, and that means you lose 3 marks. Okay, let's continue. Okay, this is the formula for a quotient rule. Let's do an example here. Suppose we are given y equals maybe x squared over e to the power x, and we are asked to find the derivative of this y prime. Okay, you see, we have a function over a function, meaning we have to use rule 8, right? Okay, let's say we let our f at x to be x squared, and then we let our g at x to be e to the power x, right? Okay, but for us to use the quotient rule, we need the derivative of f and the derivative of g again. Okay, but we have f and g. Okay, let's find their derivative. The derivative of f, which is d over dx of x squared. Here, we'll use the second rule, right? X to the power n. So this means we'll have 2x to the power 2 minus 1, which is 2x, right? And then we want to find the derivative of g2. So you say d over dx of e to the power x. We said if we differentiate e to the power x, we'll find e to the power x, right? Now we have f and the derivative, g and the derivative. We need the lower parts, g squared, everything squared. Then we substitute back here. Okay, so this means your x squared over dx, the derivative of this would be, we said it's we said it's g, your g is e to the power x times the derivative of f. The derivative of f is 2x, right? Minus you keep f minus f is x squared times the derivative of g. The derivative of g is e to the power x, so it's x squared times ex over g squared, so over ex all squared, right? Then you simplify, you simplify this. If you simplify this, you see the constant is in the middle. We said we'll always put it in front. So we can write this as 2 e to the power x minus x squared ex over ex2. Here, it doesn't matter whether you want to start with x or ex. You can also write this part as 2x e to the power x. This is the same thing as this. Okay, don't forget this minus.
Sorry, ma'am.
Yes.
The denominator, can it be e2x? Just to simplify it.
Yes, if you simplify this is e to x, but you can leave it like this. Okay, but if you simplify, it's like this. Any more questions?
Sorry, ma'am.
Yes.
The EX, it's a denominator, right?
Yeah. Yes.
So if it's a denominator, isn't it supposed to be like 1 over EX? Or can it be just an EX on its own?
1 over ex.
Yeah, isn't it denominator? Isn't it 1 over that's
ex squared? If you want to write it like this, okay, that means you have say if we put brackets, you write 2x e to the power x minus x squared e to the power x times 1 over e to the power 2x. Then you can write it like this. It's still the same thing. Just make sure you
Okay,
have
thank you.
brackets to show that it multiplies everything here.
Oh, okay. No, thanks.
Okay. Is it fine? Okay, let's try another example. You.
Sorry, could we not simplify that a lot more and have it be
You don't simplify them.
2x minus x squared over e to the x?
2x
minus x squared over e to the x. Because if you take the ex out of the numerator and cancel one of the x's at the bottom.
Yes, you can take this out and have 2x minus x squared.
Yeah, and then it cancels
should
out
be
one of
over
the x's at the bottom.
Yes, you can leave it like this.
Okay.
I don't think I'll simplify it further to this part, but this is still correct. Okay, y equals 1 plus x squared over ex. Here, you can say, let's f at x equals 1 plus x squared. And let's g at x equals ex. Then you solve for f prime. F prime would be the derivative of this is 0, then the derivative of this plus 2x. Here we are using rule 1, we are using rule 2. Okay, the derivative of e to the power x is e to the power x. Then you take everything, you substitute back here to your formula. If there is a need to simplify, you simplify. If there is no need, then you leave it like this. Is it possible that you can give me 5 minutes to do the chain rule? That's 5. Maybe it won't even take 5. 2. It's just that on our next
It's okay,
section,
ma'am.
I want
Yes.
to start the application. Then after the application, you'll be able to write assignment 2. I know some of you did write assignment 2 already, and there was an error in assignment 2. No one said anything. The explanatory.
Can you scroll up a bit, ma'am, because I've missed something on the last example that I've made.
This one?
Scroll up more so that I can see the original equation of that solution.
Here's the original equation.
Yeah.
From the example I did.
Yeah. Okay, thank you. Then you can continue.
Right. The chain rule. Okay, sometimes this rule is called a function over a function of a function. Yeah, a function of a function. Because this means you'll have a function or an inside function and an outside function, because you'll have 2 functions here. Okay. Here, you have the derivative of y with respect to x will equal to the derivative of y with respect to u. U is a new function. You'll always have to define a new function or spot a new function. Yes. dy is equal to du. It's dy over du times du over dx. Your function, your y function will be given in terms of x, but it won't be easy for you to use our rules if your function is given in terms, sorry, it's given in terms of x. That's why you have to come up with a new function. Okay. This is how you will define the inner function and the outer function. Okay, let's go back to our rule. We have a rule for finding, okay, a rule for finding x to the power n, right? We have a rule for finding e to the power x. We have a rule for finding ln x. We have a rule for finding, let me see, e to the power n, e to the power x, ln x. Okay. Yes, like this, you can put them like this, because if y is equal to 1 over x, you know that this is the same thing as e to the power minus 1. So that means your n is equal to minus 1. So, okay, my point is you have a rule for finding this, you have a rule for finding this, a rule for finding this, and this, right? So, since you know these rules, suppose you are given something like this, y is equal to 10x plus 9 to the power maybe 10. You see here, you can't, it's not easy to use any of the rules here, because you have a function inside to the power n. You don't have just variable x to the power n. You have something to the power n. So this is what you'll do. You'll take this function and see if you like, let's say manipulate, let's use that word, that's fine. Manipulate this function, which function is the closest function that you can get from this. You have x to the power n, you have e to the power x, you have ln x. You see, if you have this function, the closest function to this function compared to these three, it's this one. It's x to the power n, right? So let's everything that is inside here to be another variable. So let's name that variable u. So let's say you have y is equal to u to the power 10. We said your u is equal to 10x plus 9, right? You have a function, inside function and the outer function, right? We have, you see from here, we can use rule 2, and we can use another rule here, rule 2. It's easy if you separate them like this. So this means we write y is equal to u to the power 10. Again, if you had something like this, y equals to e to the power 10x plus 9. You see that this function is closer to this one, right? So this means your new variable should be this, so that you'll have e to the power 1 variable, and that variable is equal to 10x plus 9, right? Again, if you have y equals ln 10x plus 9. This function, you need to write this function in this form, for you to be able to use one of our rules. So, okay, you see here, you have ln of one variable. So you can just change this to be one variable. So this means you can let your y to be ln u, where u is equal to 10x plus 9, right? But what does the chain rule says, right? Okay, chain rule says your dy over dx, if you have a function of a function, if you have an inside function and the outside function, then your derivative would be the derivative of y with respect to u. That's why we have a new function called u. But it doesn't end there. You have to multiply that derivative times the derivative of u with respect to x. Okay. First, we have y equals 10x plus 9 to the power 10. And we said this, we can write this as y equals u to the power 10, whereby u is equal to 10x plus 9. Then the chain rule says dy over dx is equal to dy over du, meaning we are differentiating y with respect to u, times now differentiate u with respect to x, because u is the function of x, and this y is now a function of u. It's no longer a function of x because we introduced a new variable, which is u. Okay, we have u, we have y, and u. We need to find the derivative of y, and we need to find the derivative of u. Then you see, now we can use our rules here to solve, to find the derivative. Okay, you go back to rule 2. Rule 2, your n is 2, is 10. So this means dy with respect to u would be 10u to the power 10 minus 1, right? Times the derivative of u with respect to x. We are differentiating this now, right? Okay, you differentiate this plus you differentiate this. You know that the derivative of this is 0. So this means here we'll have the derivative of this, right? So this means we'll have 10 times d of dx of x, because we take out the constant, right? So this means we have 10u to the power 9 times 10. The derivative of x, we said the derivative of x, we use rule 2, right? So this means we'll have, take n, our n is 1 here since we have only x. So we have 1 times x to the power 1 minus 1, right? And this is 0. X to the power 0 is equal to 1. So this means here we'll have 10u to the power 9 times 1 times 1, which is 1. So this means we have 10u to the power 9 times 10, right? Okay, then we can simplify from here. 10 times 10. 10 times 10 is 100. So we have 100 u to the power 9. You can't leave your answer here because remember, the function, your function was given in terms of x, not in terms of u. You only introduce u to help you use the rules of derivative of differentiation. Now you need to put the value of u back. We said your u is equal to 10x plus 9. Then go back to your answer. Where there is u, you put 10x plus 9. So this means we have 100 times 10x plus 9 all to the power 9. Okay, this is your answer. Okay, now suppose you have y equals e to the power 10x plus 9. I said, if you have something like this, the closest function here is e to the power x, meaning e to the power 1 variable. Okay, meaning we can write this as y equals e to the power u. If you write u here, this means your u is equal to 10x plus 9. Okay, the chain rule says if you have a function like this and you want to find its derivative, as in dy over dx, then your dy over dx would be dy over du, meaning you're differentiating y with respect to u, times du over dx, d of the new function with respect to x. Okay, we have e to the power u, the derivative of e to the power 1 variable, it's that function. Like the derivative of e to the power x is e to the power x. So this means this part would be e to the power u times the derivative of this. Okay, if you want to find the derivative of this, we did find the derivative du over dx if u was this, right? We said it would be 10. Remember here. This is, we said it's 10 times 1 and 1 times 10 is 10. So if u is equal to 10x plus 9, then du over dx would be 10. So this means we have 10 here. So 10. So this means we have 10 e to the power u, right? And we said, okay, we don't leave our answer in terms of u because our original function was given in terms of x. So substitute this u back. So this means we have 10 e to the power 10x plus 9. Then this would be your answer, right? So again, if you had 1 equals
This is like a
lim-
long trick question. Way easier.
Yes. Whoa, man, whoa. Yo.
Right
This is
now,
too
ma'am,
much.
I feel like you are speaking a language that I don't even understand. Yo. I've understood all the rules, but this one, yo, I
This
keep
one
on
is like
losing you.
climax of rules. I don't know. Yo.
Maybe we'll have to. Maybe we'll have
I
to
thought I was
practice
following
this
you, but
time.
I lost you somewhere, man.
I've never
maybe
practiced.
okay, I'll do this last example, then I'll give you guys questions to do. Then on our next session, we'll start with those. I'll start with this section, with this rule again. Then we do those exercises. Maybe after you went through it, when we come back, it would be easy than now. I don't know.
Okay.
You'll have to go back to the recording and do the exercises, and then when we come back, we do the rule again. I guess it would be easier that way.
Yes, please, ma'am. Yes, please.
Okay.
So, ma'am, if you were
Here you have, if you were to say,
if you were to tell us that how many percentage will differentiation in the exam, like if you would estimate, is it maybe, does it contribute 10%, 5% towards the exam?
remember I said if like if I lose you here on this section, that means you won't read the next 3 sections because the rest of the sections relies on this one. Because okay, the next section is the application of this, right? Then after the application of this, we'll do the inverse of this section. Okay, like first we have y equals e to the power n, and we said the derivative of here is n times x to the power n minus 1. In the inverse, we'll be given maybe y equals
Sorry, ma'am. Sorry,
yes.
sorry, ma'am. Sorry to cut you. Are you also gonna post this on YouTube? Because I'm gonna have load shedding at 8, and my laptop is gonna go off because it survives on life support.
Yes, I will post all the recordings.
Okay.
Okay.
All right.
I was saying that the inverse of this, that's where you'll be given this function and you will be asked to go back to this function, right? Here we are given this function, we are going here. Then the next section is the application. The section after that, you'll be given this, you will be asked to go back to this. And you won't be given this function. So you'll be given this and asked to go back to the original question, not knowing what was the original question. So it's better, you have to make sure you master this function, this section. The part that you did with Prof, I will say that it's 30% of the exam.
Oh no.
Like those were the basic. We are still introducing the module.
If
Yeah.
it was 50%, I was going to study only that part. Oh, trust me. You.
Same here.
Like you see that part. The next section here will be solving those equations that you solve with Prof, but we'll be using this method. We'll be using the differentiation, solving the first part. Then you do the second part, which is the inverse of this part. Then the last part, you go back to the equations that we're solving with Prof. You'll be solving using the inverse of this function.
Yo, ma'am, that's
Yo.
like that's
Yeah.
forward and backwards the whole
So
time.
that one's like 30%. Mm-hmm.
Yeah, ne?
It's half, ne? So Ganda.
And
Inverse in
maybe
the
if you can
original.
change
It's
classes,
very mean.
I guess up to answer at the end of the day. Yo.
How do you apply this in real life, though? Yo.
You will see in the next chapter.
Or the application of differentiation. Okay. I hope it makes sense. It was like a mind game, it's like between inverse and coming back to the original. Like, what for? But I'll see.
Yeah.
But thanks. I just want to say that. Thank you.
So ma'am, does this module have the like DSC 37 something?
What does that module have? DSC 37?
Yes, like this one, Ankiri, it's DSC 1520. So do you have DSC starting with 3?
It's for third year.
Like maybe there's DSC 3715 or 37 something.
Oh, okay. If you fail this module and the other, which is DSC 1630, you won't be able to do second year.
I'm glad this is the first and the last
Second
time
year
for me.
module.
Me too. Me too. It's my final. Yeah, this is one. It's the only one. Yo.
Yeah, this is the only one for me. Thank you. Good luck, guys.
Like I don't know what.
Miss Ngoma,
I'm only starting here, guys.
please ask, do you have a breakdown of in the exam how many questions from each chapter percentage wise?
Nope.
Do they normally spread them evenly
I
or?
don't. Okay, I'm still going to calculate. The thing is, for now, I'm still typing. I will know before. Yes.
Okay, can I ask,
Miss Nkomo.
is this got to do with projections eventually? like future projections when you do business calculation on either
Yes.
marketing or how the business is gonna operate in the future?
Yes.
Okay,
Okay,
thanks for
that's
answering.
the other section. I think the third section from here, the inverse of this. This one will help you maximize or minimize the profits. Because we still have to find the second derivative. Like, okay, when we differentiate a function twice, like you'll be given this and you're asked to find the second derivative, like you differentiate twice. Here, we're differentiating a function once. Then the second derivative, you differentiate twice. And the second derivative tells you whether the profits will increase or you'll have a loss.
Ms. Ngomo.
Okay, thank you, Ms.
Yes.
Nkuma.
Ms. Ngomo. Ms. Ngomo.
Yes.
Ms. Ngomo. I have a question. Can you, like, I have a suggestion. Can you, like, if we finish, like, using the study guide, can maybe you use previous assignment and past exam papers? Because, like, when you're doing assignment and exam is a different format, they can make the question more harder.
It can never be me. Like what you see here, it's what you'll find in the exam. Okay. I don't really like to use the past papers because I only started teaching this module in 2021, and like the way I set the assignment and the exam, it's completely different to the person who was teaching before. For me, I use the study guide, the examples, the exercises.
So if you master everything in the study guide, you are good to go.
Yes, you can even get 100%. Okay, this is what
Okay.
I
And
would do.
also the
Ne?
book exam.
Before you write assignment what? Assignment 5. I will release the rest of like all my questions, the past exams questions. But I'm not going to give you guys the solutions because maybe Prof took from those questions, I don't know. So you guys, you can just use that as practice and see. Yeah.
Are you not gonna forget? Should we remind you, because you normally forget to record sessions?
I'm getting old.
Should we remind you before we write assignment 5 that you give us the whatever you just said now?
Yes, because